Assalamu alaikum everyone, welcome to Make It, and this is me Shoaib again with you guys with a new video. And obviously the project number is 02, that means this is my second project, and the project name is motor driver circuit. So first of all, let know that what is a motor driver circuit. A motor driver is an electronic device or circuit that provides the necessary power and control signal to drive an electric motor. So let me make you understand that you have a motor, right? You have a simple motor here, and you have to rotate this motor, right? So it's very much simple that you just connect to a DC supply. If it's a DC motor, then you just connect it to a DC supply, and the motor will start rotating. But your target is not to rotate the motor only. You have to control this motor, right? Then how can you control? You can just vary this DC voltage and you can control this motor. But there is the problem. There is the question that how can you control this DC supply? So you can make a circuit, simple circuit, like you can use resistor, potentiometer, whatever. But the problem is that if you use the resistor type circuit, then there will be the huge current loss. I mean the huge heat loss, and the rest of the power will be lost unnecessary. So this is not the convenient way. And again, if you want to control the speed precisely, you have to take the feedback. So for taking this feedback, what you have to do, you have to make the feedback circuit. So ultimately direct controlling, I mean direct using potentiometer or resistive type circuits is not convenient to run these types of motors. Okay, again these types of motors actually drive lots of current. So you have to take care of your circuits as well. So what you can do, you can use a conveyor circuit, right? And what is the conveyor circuit is, there could be many, but in this video what I am making motor driver circuit using HB circuit. That means I am using power MOSFET IRF 540, and which is at 4 number, I mean 4 ICs to make an HB circuit. Like this is a switch, this is a switch, this is another switch, and this is another switch. I mean these are the MOSFET, and I am calling this thing switch. That's it. And the load will be here, I mean the motor will be here, and naming the switch like S1, S2, S3, and S4, simple. So you look what happens when the supply, I mean when the S1 and S2 is closed, that means the current will flow in this direction. Okay, when for this reason you have to keep open this S3 and S4, otherwise this part will be shorted, and uh, bad thing will happen with the circuit. So when S1 and S2 is closed, you have to keep open S4 and S3, and the current will flow in this direction, and suppose the motor is rotating in clockwise direction, right? So you have selected a direction of the current of the uh, motor rotation. And how can you control? You can use PWM signal. So I won't talk about best in, I mean in large, in detail, what is PWM signal, but you can know that PWM signal is something like that. It's a square wave, but you can change the pulse width. I mean, you can see that it has if it's a it has a t period, time period, and the on time is t by 2, and off time is also t by 2. That means that it has a duty cycle of 50%. Okay. So this is how you can change the pulse width. That means that this width or this width, whatever. So you can change the percentage of this pulse width. You can make 80% or 100% or whatever. So 100% means you are supplying all the voltage to this load, I mean to this motor. That means if it's a 12 volt uh, and you are making the pulse width 50%, that means this motor driver, I mean the motor will take 6 voltage only. Okay, if you make the pulse width 100%, that means it will get approximate 12 volt, right? This is how the system works. So how can you give this pulse width to this circuit? You need the circuit connection. You have to make the circuit for this pulse. Okay, so all of the things will be done in this video. And one thing you have to say, that suppose you have to change the direction of this rotation. At this first case, the current was rotating in this direction and the motor was running in clockwise direction, suppose. And now you have to change the rotation, like you have to rotate the motor in opposite direction, in anti-clockwise direction. So you have to run the motor in this direction. I mean, you have to open again S1 and S2, and you have to close S3 and S4, so that the motor should run in this direction. I mean, so the current should go through S3 and S4. That's it. Okay, so it is our concern that how can we make this PWM signal, and how can we give supply to this MOSFET or to this driver circuit. So I don't need to clean all of the things now. Going into the next slide. Yeah, this is the working principle, and actually I have told you most of the working principle in the first slide. Now I will talk about the rest of the things. Like it has sorry, I have a little bit problem in my for the cold reason. Okay, so I have to say that it has three main parts. One PWM generation part, second one is a boost up circuit, and third one is switching circuit. So you can see the schematic diagram. Okay, so this part is used for generation of the PWM signal. That means for this reason I am using 555 timer IC. I won't talk about that how each of the IC generates the pulse. That I will just talk simply. Okay, this 555 timer IC generates the raw PWM signal, that what I have talked to you at the very first time. I can also change this pulse width using this potentiometer, and this pulse width signal will come through this wire. Okay, so this is the PWM generation side. Okay, you can supply this PWM with any types of Arduino or microcontroller also. Okay, that will be convenient. So actually we use this microcontroller for what? For taking the feedback and for the automatic precise control, right? Okay, and then you have this part for boost up. So why this boost up? It does two types of work, two works at once. One is boost up, a second one is to protect this PWM generation circuit. Suppose you are using microcontroller. So microcontroller is a sensitive things. Okay, it's a expensive things. If somehow the high current pass through this microcontroller, I mean from this side to that side, these things could harm to this microcontroller. Okay, so we don't want this. So this boost up circuit can also work for you to protect the microcontroller circuit. I mean, you can say that it's a protective circuit also. Okay, protection for. Okay, so another one is boost up. Boost up means you have these types of power ICs. You have the gate and source part, and you have to give the supply to the gate and source. Simple. But in a normal BJT, you can give a little bit voltage, like these things work approximately in 1 to 3 voltage. Simple. But you can't run with 1, 3 or 5 volt these types of huge power MOSFETs. You have to provide at least 10 to 15 or more voltage to run these types of voltage. I mean these types of MOSFET. So you have to it will provide this PWM at a level of suppose 5 voltage, but you can supply this 5 voltage to these types of MOSFETs. So for this reason you have to use this boost up circuit, and the boost up circuit will make the same replica of the signal but with a higher level of voltage, like 15 voltage. And you can set this higher level of voltage like by providing this voltage at VCC level. Suppose you are supplying at VCC level 12 volt, this voltage will be also 12 volt. Okay, so this is how the thing works. And then I have to clear these things a little bit. Okay, and the boost up signal will come through this side, and you can see that I have used an SPDT switch. This is for what, I can change the direction of the motor by using this switch. Because if I am making this connection like okay, let me zoom a little bit. If I make this connection, that means the signal is going through this way and operating this Q1 and this Q2. That means my motor is supposed running at clockwise direction. If I change the switch from this side to this side, that means the getting signal is going through this way and running this Q3 and Q2. Okay, so now the motor is rotating at opposite direction. So you can change the direction of the motor by just switching this switch, sliding this switch, SPDT switch. That's it. And another thing is that I have to use obviously these two resistors, which is very much important. Because what, you have, suppose you have to change your direction, but the problem arises for the capacitance of between this gate and source. Okay, each of this MOSFET has the effect of this capacitance at its gate between the gate and source of each motor, each MOSFETs. So for this reason, these MOSFETs keeps open even I have switched this to the another combination. Okay, so these things makes the circuit short, and this is very much bad for our purpose. Okay, so for this reason, what we have to do, we have to discharge this capacitance, this capacitor, through somehow. So if you connect this resistor, that means the capacitor, these two capacitor will discharge through this resistor to the ground. Then the MOSFET will be completely shut down, completely off. That means no problem, any problem with the short circuit. Okay, so this is how the thing actually works, and you can take the output from this portion. Okay, so this is how the theory about this circuit, and I will take you to another new video where I will show you how can you just do these things in a Proteus simulation software. Okay, and you can also make the PCB design to make the whole circuit in physical world. Okay, let's go. In this video I will show you how you can draw all of the circuit in Proteus simulation software. So actually I am not showing you how to draw. You can see the connection diagram I have already shown you in the last PDF section. So you can draw all of the things like this. Okay, what I am showing you in this screen, but I am sorry that I can't simulate these things at this moment, because there is a little bit problem with this TLP250 IC. It's not running, but rest of the things is running very much well. But the problem is that at this moment I am sorry that I can't simulate these things. But after drawing all of the things, circuits in this schematic capture section, you can go to the PCB layout, and when you go to the PCB layout, you can just place all of the components one by one, and you can route all of the paths, all of the components manually also, and you can do it automatically. But the manual routing or manual placing gives you an advantage that you can make the PCB one layered. Okay, so if you suppose all of the things are very much congested, then if you make these things auto router, if you place these things in auto router section, auto router option, it can be two layered. That means the conductor part, the copper part, will be at the both upper side and also at the lower side. Okay, this is the little bit advantage of that, but otherwise there is no problem with it. So I have made these things in auto router mode, so it has shown me both of these two layers. That means the upper layer, you can see the red mark path, these things goes at the upper side, and the blue part goes for the lower side. So that's it. You can see this thing in 3D visualization, and you can see something like this. Okay, so this is the upper layer, and you can see all of the components at this upper part, and also some path, you can see this came to this upper section, because this is two layer. One layer means the copper part, I mean this routing path will be at any of the layer, I mean either at the upper layer or at the lower layer only. This is the potentiometer. You can see this is the potentiometer. This is the potentiometer. These are the capacitor that I have used. This is the 555 timer IC. This is the TLP IC, and this is the rest of the things like resistor, and this is the SPDT switch, and this is the big powerful MOSFETs. And you can see the bottom layer as well. So this is how we can design a 3D visualization of this PCB layout. Okay, further if you want to design this, I mean print this circuit, you have to make the Gerber circuit, and you just order the PCB from wherever you want to be printed. So this is how for today. And there is another video section where I will show you how this thing actually works in real life. Okay, so I have to say that this project is 100% working, right? So you can use this project in real life. I mean, you can use these things in your college project, in your university life project, wherever you want. Okay, I am making these things free, and I will just attach these important files according. I will attach all of these important files regarding this project in Google Drive, and I will share you the link. You can get these files from there. So this is it for now, and I have to say bye, and I have to say one thing, that is please stay with me, and like my videos, comment, share your thoughts, stay with me, connect with me, and just motivate me a little bit. That's it. That's all. I just try to make these things for you guys. So this is it for now. Thank you so much. Bye. This is the whole motor driver circuit, and it has main three parts. One is to generate the raw PWM signal, and second one is to boost up the signals to drive all of these MOSFETs. So first block is this one, which is the PWM generation section, which is done by this 555 timer IC, and you can see the PWM signal in this oscilloscope, which is very much beautiful. And you can change the pulse width with this potentiometer. You can see I can change the pulse width, and then this PWM signal is boosted up by this white IC, which is TLP250, and the signal is fed through this red wire and diverted into two paths with this switch, and these things power ups these all the MOSFETs with the KT signal. Okay, and this is my motor. I don't have any blades at this moment, so I have to use this clip as blade. So I am powering the whole circuit with this DC power supply, which things is made by me also. And then I'm just switching these things to run, like you can see that, yeah, the motor is rotating in anti-clockwise direction. You can see that, and I can also change the speed. I'm lowering the speed now, and I can also increase the speed very much easily with just moving this knob. Okay, and I can also change the direction. You can first of all you have to neutral this switch. Okay, first of all you have to neutral this switch, and then just slide this thing into the left side. Okay, so you have to power this thing up. What happens? Okay, you can see the first time the motor was running at the anti-clockwise direction. Now it's running in the clockwise direction. So the circuit is 100% working. Thank you.